Hey guys, in this video, we will build one simple animation project using Python Turtle module. So we will basically create a turtle object, which is circle, which moves from left to right and bounces when it touches when it hits the screen edges. And it's for a beginner who is just getting started in Python and he's getting his hands dirty in Python Turtle module. So to explore the basics of turtle graphics and animation, we will, build this project. So let me show you what we are going to build first, and then we will dive deep in on the coding part. So let me run the script first to show you what we are, building. So uh, bouncing circle window screen, we have one circle object which moves from left to right, and when it touches or hits the screen edges, it bounces in the reverse direction. So this happens continuously. It's a continuous animation. So without further delay, let's get started with we will build this amazing animation project. So before diving deep into the coding part, we have to understand the requirement first. Like we have to split the complete program into a smaller chunks so that it will be easier for us to build. So you have seen the you know uh, the turtle window, right? Like if you see this particular output, you can divide the requirement. Like the first set of requirement is going to create the window screen. Like you have to set up a turtle screen for as a base to our project, and the second task is to create a circle object, and the third task is to move that circle object in the screen, and the fourth task is to handle the boundary detection. Like when the object hits the edges, it has to reverse the direction. So that part we have to handle. And the fifth task is to do the continuous animation. Like it has to keep on doing what it is doing till we exit the screen, till we exit the turtle screen, that the module screen. So these are the five tasks that we are going to work. So without further delay, let's get started. Let me clean up the screen. Let's start with our first task, that's setting up the turtle screen. So let's first import the turtle model. Turtle is a built-in model, so you don't need to install the module explicitly. And let's first create the screen object. So for that, you need to use the screen method from turtle. And then let's set up the title for it. And give the background color as black. And oops, and also we set up the size of that screen to width and height as 600. So now we have created the screen, and we have given the title for that screen and also the background color and the screen size and all. But the important thing is to keep that uh, keep that screen open till we exit the window explicitly. So for that, we have to use the main loop method, which keeps the uh, screen available for all the time. So let's execute the code to see whether this is working fine or not. Yeah, we have a window screen now with the title bouncing circle, and background color is black, and also the width and height of the screen is 600. So width is 600 as well as the height is also 600. And the main loop method keep this screen available till we exit the screen. So now we have done with our first task. So the next task is to create the simply creating turtle object with a variable name as circle, and now we give the shape to the turtle object as circle. As circle, and then we give uh, color white, and also we use pen up method. I will explain this part later, the pen up method later. Now let's run the code. You see, now we have a circle object that is exactly at the center of that turtle screen, which is our bouncing circle screen. And now we will go to our third task, that moving the circle object on screen. Now uh, let's write a code for moving the circle object. So first, let me set the speed for that circle object. I will set that to 3, and circle direction to 1. This is just an initial parameter I'm using. You can create whatever you want. So 1 means right, which means that circle object will start to move from left to right. So 1 means right, whereas -1 means it will reverse the direction to left. And then uh, let me set that max exposition to, that we will split that screen width size. We will go width, then we will divide that by 2. So what I'm trying to do here is like I'm trying to set the circle speed, the speed at which the circle moves, and then the circle direction. So here 1 means right, and the -1 means left, and then max x. We are kind of splitting that screen, because if you notice that right now that that circle object it's in the center, exactly the center. So let me use the snipping to explore more. So uh, right now we have a screen with width as 600, and height also 600, but that the circle is in exactly the center, so means uh, to the left of the circle it's 300, and also I'm sorry, this is right, so this left of the circle is also 300 and right of the circle is also 300, because the circle present exactly at the center. So that's what I mean. So when what we are trying to do is like we are trying to set the max x, because the circle is going to move only in the x direction, from left to right and right to left. Right to left in the sense when it touches the edges, it will bounce back in the reverse direction. So the maximum distance it will travel is only 600, because we set the width to 600. Since it start from the center, the circle to the right of the circle it's 300, to the left of the circle is 300. So that's what we are trying to do in that line. Like we set the max x to 300. So means the circle we can travel maximum of 300 to the edges, and when it reverses, when it comes to center, it will travel maximum of 300 to the right. So that's what I'm trying to mean. So once we done with our third and fourth part, you can understand much better. So now we have defined our initial parameter. Let's proceed with creating that function for moving the circle object. So let me create a move circle function, and I'm using direction variable, sorry, circle direction variable. And then uh, I'm taking the circle position, current circle position, so that I can get the detail of where that circle is. And now I will, simply set the uh, direction to, so now let's call this function move circle. So now notice the changes. I have a screenshot, right? Currently it's in the center. Now if I run it now, okay, sorry, there is a mistake. It's a method. I have to put open and close bracket. Now let's run it. It's moved, but it's not, visible to our naked eye because it's executed in a fraction of a second. It has slightly moved, but bear with me, it has moved. We will come to that fourth task. There you will clearly see it is moving or not. Now we have to write one condition, so that you can check if it touches or not, because the fourth task is to identify if that circle hits the edges or not. If it hits the edges, it has to reverse the direction. So right now, let's assume that the circle is starting from the center and it moves and it travels till 300. When it's 300 means it is here in this position. So which means it touches the edges. So it has to reverse back. So when it reverses and it travels in this direction, and when it hits this direction, this position, which is minus 300, then it has to reverse back from here. So that's what we are going to do. We are going to get the current x position, and we are going to compare, like, whether it is in the 300 position or minus 300 position, uh, and whether it's a less than or greater than a condition. Based on that, we are going to reverse the direction. So we reverse the direction in the sense, you have already noticed that I have set 1 for right and minus 1 for left. So when it touches the 300 position, so that time I'm going to simply define the circle direction to minus 1. So minus 1 means it will travel back from the edges. So it will move from edges to this direction. So when it reaches this position, that time I will reverse the direction to plus 1 again. So here I will change to minus 1, here I will change to plus 1. So that's what we are going to do. So I'm going to simply write a condition. So once we get the x position, we are going to check if that x is greater than or equal to max x. Max x is nothing but the 300. You can simply, define it as 300 here. But the reason why I haven't done that is right now I'm setting it as explicitly, like I'm defining the max width to 600. In case if you are changing it to 800 or 400, this code will handle it dynamically, right? So that's why I'm going with this particular like piece of code. Otherwise, you can, use hard coded value also. So let's jump back to this condition. Or if x is less than or equal to minus max x plus 10. In such scenario, you have to simply reverse the circle direction. You can just simply multiply by -1. So now we have kind of return our move circle function, which means we have handled our third and fourth task, which is moving the object on screen and also handling the boundary detection. But if I run the program now, the changes will not be visible to our eye because it happens in a fraction of second, and it will simply move only a, a small distance. Only when it is happening continuously, then the changes will be visible to our eye. So for that, the fifth task, that you know uh, continuous animation, like moving the circle object continuously. So for that, what I'm going to do is, like, I'm going to use the turtle built-in method on timer. So I'm going to on timer, and I'm going to call the move circle again, uh, for every 10 milliseconds. Actually, it's not on circle object, it's on a screen object. Okay. So now we have written our code. We have done all our tasks. We have created the turtle screen, which is our window screen, and we have created a circle object, and we have written a move circle function, which kind of getting the exposition, and then doing the operation, the conditional check to reverse the direction, and the fifth task, like the continuous animation. So that part it is handled here. So let me run the code to show you what it is. So now you can see, right, that circle is moving from left to right, and when it touches the edges, it reverses the direction, and same when it travels in the right direction, when it touches the edges, it reverses, and when it travels in the left, when it touches the edges, it reverses. So now, to show you much better, I will explain the code once again. And the first thing that I have left is this pin up method. So the reason why I have used the pin up is, if you haven't used the pin up, it will draw a line in that direction. Let me comment this code and run the code again. So you see now, the pin is actually down. The turtle object pin is actually down. So that's why when it moves in some direction, it start to draw a line. And same wise, when it reverses the direction, it actually writes the line on top of that line again. So that's the reason we are using the pin up to take the pin so that it will not draw a line, and we will have a clean animation. And the next thing is this piece of code. You may ask, like, why you have used 10 here, -10 and +10. So if I'm not using -10 or 10, what will happen is, like, this will travel, the circle will travel till the edges. So what will happen is, like, so here you notice, right, it will travel till edges. So half of that circle will be hidden in the sense, because it will go till the edges. So that we don't want. We have to make that circle visible to our eye, that it actually touches the edges. So which means it will be okay if it travels till 290 position or -290 position. So that's why we are using +10 and -10. So let me show you what I meant. Like, now I have removed -10 and +10, but I will run the code. So you see, when it touches, you see half of the circle has hidden, half is hidden in the window. That we don't want. We want to show the circle like actually it hits the edges, not like it is traveling inside the edges and bounces back. So that's the reason we are using plus and -10. And I will also print that exposition to make it more clearer to you, like what is happening in the code. So you see, when it started from center, it jumps to third position, sixth position, ninth position, because we set the circle speed to 3. It's actually not the speed, it's actually the distance. So that's why, when we ran the animation, it kind of uh, visible to your eye as the speed, but it actually the distance that the X is traveling. So here you see it starts from 0. Let me stop the execution first. I think it has crossed the limit. Let's see. Okay. So here it starts from 0 and it travels to 3, 6, 9, multiples of 3. And when it reaches the 290th position, from here, 291, it start to reverse back. So you see here, it is kind of reducing -3 from the 290th position. Likewise, it is reducing -3 from the current position, and it travels back and it reaches, when it reaches 0, it moves in the negative x-axis, which is -3, minus direction. So when it reaches the -290 position, you see here, when it reaches the maximum of -290 position, it reverses back from that. So that from that, it start to reduce the 3 steps from it. So that's why we have this clean movement. So I hope this explains better, and this is how you will create a bouncing circle animation using Python Turtle module. I hope you have enjoyed this video. I will include this code in my GitHub repo, and I will give the link in the description. You can check for reference. And if you have enjoyed this video, please hit the like button, and also please don't forget to subscribe. In the next video, we will build the same project, but next time it will be a diagonal movement, like a random movement, instead of single line movement from left to right and right to left. It will be a diagonal and random movement. See you next time. I hope you have enjoyed this video. Thank you for watching. Have a nice day. Bye.